Okay, this was a test on exponential functions. So if you're still studying exponential functions, this will be a good review for you. This is part 1. In this video we will graph exponential functions and talk about transformations of exponential functions. Okay, so problem number 1. I see that this is going to be shifted down 5 and have a vertical stretch by a factor of 2. However, we will start by just graphing the parent function, which is just this part, 3 to the x power. And since we're just doing the parent function, we can get away with the following x values every time: -2, -1, 0, 1, and 2. So we are graphing the function that's 3 to the x power. Okay, so that means we're doing 3 to the -2 power, 3 to the -1 power, 3 to the 0 power, 3 to the 1 power, and 3 squared. Well, 3 to the -2 power is 1 over 3 squared, so that's 1 over 9. And then 3 to the -1 power is just 1 over 3. Anything to the 0 power is 1. 3 to the 1 power is just 3. And 3 squared is 9. Alright, notice how the top two and the bottom two are just reciprocals of each other. That will make your calculations go faster, and it's sort of self-checking. Okay, before we go graphing these points, sometimes we need a third column. We need a third column when there is an a value, and there is an a value of 2. So we'll make a third column for the a value. Alright, in this third column we are going to do the a value. So we had an a value of 2. So we're going to multiply all these y values by 2. So we're going to do 2y and put it right here. So 2 times y, that's going to be 2/9. Okay, and that's going to be 2/3. And then that'll be 2 and 6 and 18. Alright, I'm just multiplying all these by 2. So now, once we have the third column, we can really disregard the middle column. And we're just going to be graphing these. So -2, 2/9. That's going to be -2 and very close to 0. Okay, and then we have -1 and 2/3. Okay, it's going to be about here. And then we have 0, 2, which will be here. 1, 6. And then we'll have 2, 18. Now 2/18 is going to be a little bit off the graph, but we're going to graph it anyway. So 16, 17, 18, it'd be just about here. Okay, do not connect these dots. This is just our skeleton. We still have to do the shift. This -5, which unfortunately there's a dot right on it, but this -5 is going to be a translation down 5. Alright, and there's no other shifting happening. So we need to take these 5 dots and move them all down 5. Okay, so if I do that, those will be my real points. So if I move this down 5, 1, 2, 3, 4, 5, it's going to be like right here. And then if I move this down 5, there you go. And if this is down 5, okay, down 5, and last but not least, down 5, because this was at 18, so that's 3 above, so that's 3 and then 2 more. Okay. So these are the points that we have to actually graph. It will help if we know where the asymptote is. And of course the asymptote was at 0, but we moved it down 5. So this negative 5 will be the asymptote. Okay, so let's go ahead and draw that. Draw your asymptote as a dotted line at negative 5. So there's your asymptote. Now just draw a smooth curve through your 5 points. Make sure your graph goes all the way to the edge on the left and all the way to the edge on the top. So your graph should look something like this. And so that's it for number 1. For number 2, once again, let's start with just the parent function, 1/4 to the x power. So as we make our table, once again we'll use -2, -1, 0, 1, and 2. So since we are doing 1/4 to the x power, that's 1/4 to the -2, 1/4 to the -1 power, 1/4 to the 0 power, 1/4 to the 1 power, and 1/4 squared. Now when you do a negative power to a fraction, you do the reciprocal. The reciprocal of 1/4 is 4. So this becomes 4 squared, which is 16. The reciprocal is just 4. Anything to the 0 power is 1. 1/4 to the 1 power is just 1/4, and 1/4 squared is 1/16. You square the top and the bottom. Again, notice that the top two and the bottom two are just reciprocals of each other. Are we going to need a third column this time? No, we need a third column when there's an a value. For example, in the previous problem, this 2 in the front is the a value, this multiplier. The a value here is 1. We don't need a third column for that. So let's go ahead and graph these points as our skeleton right now. So we have -2, 16. Alright, so here's -2 and 16 will be right about here. And then -1, 4. Zero, 1, one, 1/4, and 2, 1/16. Alright, so 1, 1/4 is going to be very low. But 2, 1/16 is going to be so low, it's going to appear to be at 0. Alright, so this is our skeleton. Do not connect these points. This is not the final answer because we still have to do this shifting. So this -3 in this position is going to send us to the right by 3. It's the opposite of the way it looks. The +4 in this position is going to send us up 4. So let's move all 5 of these dots that we just graphed, right 3 and up 4. Okay, so 1, 2, 3, and then up 4. Then the next one is about here. Okay, 1, 2, 3, 1, 2, 3, 4. Right 3 and up 4, everybody. Okay, this one's already off the graph. It's going to be even more off the graph. But if I go right 3 and then up 1, 2, 3, 4, it'll be about here. Okay, just do your best. Alright. Oh, I missed one. Did I miss? I feel like I'm missing a point. Which one am I missing? Oh, I missed the y-intercept here. So right 3, 1, 2, 3, up 1, 2, 3, 4. This point was missing. Alright, take your 5 points and draw a smooth curve. Wait, let's do the asymptote first. The asymptote will be at +4. Show it as a dotted line. Alright, now draw a smooth curve through your 5 points. Make sure your curve goes all the way to the edge of the graph and all the way up. So your final graph should look something like this. Alright, so problem number 3 refers back to problem number 2 above. So the domain, which is the x values, is from negative infinity to positive infinity, because it goes left forever and it goes right forever. Okay, all exponential functions have a domain from negative infinity to positive infinity. The range is more limited. You have to give the range in order from bottom to top, least to greatest. So the lowest value is the asymptote of 4, and then it goes up to infinity. So 4 to infinity. Make sure your 4 gets a round parentheses. It is an asymptote and the graph never touches it, so the 4 itself is not included. Speaking of the horizontal asymptote, it is the line y equals 4. Don't just put 4, put y equals 4. It's the equation of a line. Okay, so that is it for number 3. Okay, so for number 4, given this parent function, we're supposed to describe the following transformations. Okay, these should have all been called g, so it wasn't the same as function f, because you can't have two different functions be called the same thing. Anyway, I'm nitpicking. This one has two transformations. The negative in front is a reflection over the x-axis. That -1 is a shift to the right 1. Okay, it's the opposite of what you would normally think. And that's it for A. Alright, let me delete that because I cut and pasted. This has two transformations as well. This 1/3 in the front is a vertical compression. Okay, the graph will be 1/3 as tall as it was before. And the -4 is a shift or a translation down 4. Alright, this one has three transformations. The 3 in the front here is a vertical stretch. By a factor of 3. This +2 is a translation to the left 2. It's opposite of the way it looks. And the +5 is a shift up 5. Alright, so that's it for number 4. Alright, for number 5, we're supposed to solve each equation using algebra skills. Okay, no TI-30XS multi-view shenanigans. Okay, so we want to get the parentheses variable part by itself, so let's add 6 to both sides. So that gives us x plus 4 to the 5th power is equal to 32. If I want to get rid of the 5th power, I do the 5th root to both sides of the equation. Alright, so these are going to cancel out and leave x plus 4, and the 5th root of 32 is 2. If you didn't know that, you could use your power table. Then we will subtract 4 from both sides. And that will give us x equals -2. Similarly, number 6, we've got to get this radical part by itself, so we subtract 8 from both sides. That gives us the square root of x plus 5 is equal to -4. Now, to get rid of this radical, we are going to square both sides. Alright, wait right there. Skirt! This does not make sense. there's nothing you can take the square root of that's going to give you a negative number. So right away I know this is going to be no solution. Oh look, answer lines. I guess I should use those. No solution. Okay, and while I'm over here, number 5 was -2. Okay, I'm going to keep going with the problem, but whatever we get is not going to work. I can tell you right now. So say if we kept going. Now I squared both sides, so that's going to give me x plus 5 is equal to positive 16. Alright, then I subtract. I say boy. We subtract 5 from both sides. We have, and that's going to be 11. Okay, and you would think this was the answer, but if you put 11 back in, alright, let's do a little checky check and see the nonsense that ensues. Alright, if I put 11 back in there, then I'm going to get the square root of 11 plus 5 plus 8 is equal to 4. Let's see what kind of nonsense they're talking about here. I guess I can stay with this for now. 11 plus 5, of course, is 16. So then I got plus 8, and that's supposed to equal 4. There's a big question mark. But the square root of 16 is 4. What? What? Let me go ahead and put these symbols now that I see how it's going down. 4 plus 8 is 12. 12 is not equal to 4. That is cray-cray. Okay, so this is extraneous. And since that was our only solution, then we have no solution. But you really could have stopped as soon as you saw this nonsense happening. Alright, so that was number 6. Number 7. Okay, this one's a little bit different. There's no getting something by itself. We just have to have like bases. And let's see, I can rewrite both of these as base 3. Por ejemplo, 9 can be written, that means for example, 9 can be written as 3 squared. And 27 is 3 to the 3rd power. What do I do with these? Well, I put the 4x here in parentheses, and I put the 3x minus 2 also in parentheses. Alright, especially I need it here to remind me that I have to do the distributive property. Okay, so that would give me 3 to the 8x power equals 3 to the 9x minus 6 power. Anyway, it's time for that logical jump. If the bases are equal, the exponents would have to be equal. So that means 8x must equal 9x minus 6. Nothing happened to the 3's. We're just using a little bit of logic. What happened to the 3? Did we cancel it out? Did we subtract? Did we divide? I'm never exactly sure how to answer that question. Nothing happened to the 3's. What am I going to do now? What do we do now, man? Game over! Subtract 9x from both sides. So that's going to give me negative x is equal to negative 6. Okay. That game over thing that I just said, that was from a movie called Aliens. You know, not Alien, which was the original movie, Sigourney Weaver. Aliens, the sequel, which was better. But I recommend that you not watch it because you can't handle it. It's too much for your sensitive mind. So don't see it. So divide both sides by -1. So that'll be x equals 6. Maybe when you're older, you know, after you graduate college, you know, kids mature late. these days. It's not your fault, you know, just society's gotten soft, which is good, you know, prosperity and all that. So that's it for number 7. Well, for number 8, before we get like bases and such, we need to get rid of this 1/2. So let us multiply both sides by 2, which will cancel this out. So then I will have 8 to the 2x plus 1 power. Let's see, 256 times 2. Oops. Shabow. 512. Okay, so that's 512. Now hopefully 512 can be written as either a base 8 or a base 2, since 8 can be written as a base 2. Let's look at the power table. Okay. And let's look under 8 first. So there's 512. So 8 to the 3rd power is 512. So let's go with that. So 512 can be written as 8 to the 3rd power. And then over here we have 8 to the 2x plus 1 power. Time for the logic. What happened to the 8, Mr. Burton? What happened? 2x plus 1 is equal to 3. Okay, it's a logic. If the bases are equal, the powers are equal. We just don't care about the 8s anymore. All we care about is x. So we move on. We let it go, let it go. We don't need the 8 anymore. I know, American Idol, right? Or what, like The Voice, something. Anyway, and I'm sleepy, so imagine how I would sound if I were fresh or young, because, you know, old people. Anyway, shabow. X is 1 is the point. Love it, believe it. Alright, number 9 looks a little different. What we need to do is basically get this half of the equation to the other side, and we can do that. These are cube roots, by the way. Looks a little fuzzy. We can do that by adding this chunk to both sides. Alright, adding the cube root of 2x plus 7 to both sides. So that will give us the cube root of 4x minus 1 equals the cube root of 2x plus 7. Okay, we could now take, we could cube both sides. That's what I'm struggling to say. And that will cancel out both of these radicals. So that's going to give us 4x minus 1 is equal to 2x plus 7. Yeah, so let's keep going with this. Subtract 2x from both sides. So that'll give me 2x minus 1 is equal to 7. Add 1 to both sides. And that'll give us 2x is equal to 8. And then it's time to divide both sides by 2. That is going to give us x equals 4. Okay, we should check that and make sure it works, because you never know, but I'm pretty sure it works. So I'm going to move on and just live dangerously. Alright, number 10, we got to get this part of the equation by itself first. So we need to add 7 to both sides. Foist. Alright, so that's going to give us 2 times the quantity 4x minus 12 to the 3/5 power equals 16. Then we shall divide both sides by 2. Alright, so those will cancel out. And that will leave us with 4x minus 12 to the 3/5 power is equal to 8. Now, to deal with the fractional power, you can raise both sides of the equation to the reciprocal power. Okay, so what I'm doing is, let's do this. I'm raising this side to the 5/3 power, and I'm raising this to the 5/3 power. Now, when you do a power to a power, you multiply. And when you multiply 3/5 times 5/3, that just makes 1. Okay, because these wind up canceling each other out and making 1. So that's going to just leave 4x minus 12 over here. Now over here, when we deal with a fractional exponent, we know that the numerator is the power and the denominator is the root. This is power over root. So it will be helpful if we rewrite this in radical form. So this is the cube root of 8. Okay, so this will be the cube root of 8. And then the 5th power I will put on the outside. So this is what we're dealing with. So that means we have 4x minus 12. Now the cube root of 8 is 2. And then we've got that 5th power. So that makes 4x minus 12 equals 2 to the 5th power is 32. Alright, if you did not know that, use your exponent table. 2 5th power 32. Okay, now let's add 12 to both sides. Running out of paper. Don't you know? So that'll be 4x is equal to 44. Excellent. Quick, what is that from? What am I quoting when I say excellent? I'll give you a hint. I'm sort of steepling my fingers together when I do it. Excellent. Alright, post a comment if you know where that's from. Post a comment. It's math. It's a game. It's both. Everybody's a winner. So that's going to give us x equals 11. Okay, there you go. Guess I should put that on the answer line. It's number 10. Number 9 was 4. Am I all caught up? Yep. Okay, wow, look, this video is getting a little bit long. I'm going to have to pause this mess and before I go on to the other pages. Okay, so that'll be it for this video. We'll pick up with part 2, where we will create our own exponential function that fits these criteria and other fun stuff. Multiple choice questions, whatever, some review stuff and stuff.